Class A networks. In this, the first byte indicates that it is a network. It is reserved for the network portion. And the rest of the 3 bytes, that is the byte number 2, 3 and 4, are reserved for the host part. What that means is all the 3 bytes combined, 8 plus 8 plus 8 for the host part, gives me 24 bits. And then with the total of 24 bits, using the same formula that we have used in the previous lectures for finding out the number of hosts, to raise the number of bits to the power of 2 and subtract 2. So in this case, since the bits are 24 raised to the power of 2 minus 2 gives us the value 1677214. That is the exact number of hosts that each network of class A would have. Now it's a different thing that we don't use such networks, but ideally, initially when it was conceived, that is where this was the number that was thought about, that there will be fewer number of class A networks, but each of the class A network would have a huge number of hosts. Okay, and then if the value of the first byte of the IP address falls under the category or in the range 0 to 127, or in fact more precisely between 1 to 126, then we say it's an indication that it's a class A network. Now I have excluded 0 and 127 because those are reserved, and they are reserved for a special purpose. Okay, so let me take an example of class A networks, and that will help clarify the same concepts further. Okay, so taking the example for class A IP addresses, we are given an IP address 10.20.30.40. I just taken a very simple example. Now the requirement is, or the question or the task in hand is to identify the network part, identify the broadcast address, and identify the first and the last host. So let's get going. So the IP address that is given to us is 10.20.30.40. Just now we covered that the first byte is reserved for the network part, and these 3 bytes are for the host. So using the same rule that we have applied in the past, I'll leave the network part as it is and set the host bits to zeros. And that will give me the answer for the first question. This is the network address. Okay. Second is to identify the broadcast address. Now, same thing, keep the network part as it is and set all the host bytes and or host bits to all ones. So 8 bits here, all set to 1, and corresponding decimal value will give us 255. 8 bits binary, all set to 1, equivalent decimal would be 255, and likewise same thing for the 4th byte. So this is our broadcast address for this particular IP address. Okay, and then to identify the first host, simple. You have the network address, then you increment it by 1, gives you the first host, and then the last host is simply whatever is the broadcast address, reduce it by 1. So this is example number 1. Let me take another example just to showcase how the host values increment across the byte boundaries. Okay, and then we'll wrap up the class full IP address discussion. Okay, the question is, we have to find out the next 2 IP addresses for these 2 IP addresses. So let's do it. The first IP address is 10.0.0.254. Obviously the next one for that is simple. You increment it by 1, so it becomes 255. Now remember, this is the maximum value, so the next one, if you have to increment, it is going to get incremented like this, and this is going to become 0. So this is the answer for the first question. Now similarly, working on this one, you increment the last byte by 1 and it becomes 255. So this is the first immediate after IP address, and then the next one is 20.1.0.0 would be the answer for this one. Okay. With this, we will wrap up the discussion on classful IP addresses, and now we will move on to the classless section. And before going there, I will also, in between, discuss the importance and the concept of subnet mask or network mask. Okay.